Welcome back. Now this is another important topic which is on landslides, and as I discussed in the previous lectures that landslides are extremely hazardous in the hilly terrains. So in this topic we will try to cover the different type of mass movements. So I would like to say mass movements because there are a number of different type of landslides and landslip, mud floors. So in totality we can consider this as a mass movement. So landslide, if we define as either a very slow sliding of the material sitting on the slope, or it may move very fast also. So even depending on the slip of the material, different mass moments have been classified, either it is in mud flow or landslides. So landslides or mass wasting, we can say. Okay, so downward, it is, if we take the definition, okay, it is a downward movement of slope material due to gravity. Material may comprise of rock fragments, soil or artificial fill along a defined, or we can say along a definite plane or a prominent boundary. Movement may be in form of falling, that what I was talking about, that it may have a different speed, okay, either it fall or it slide or it flows, okay, or we can have a combination of both. Mass movement mainly occurs on slope. So we need, this is an extremely important parameter, we need slope. If we don't have slope, we will not have any mass movement. May be influenced by natural processes or human activities. Okay, so if you interfere the slopes and if you destabilize the slopes, you may face landslip or mass movements. Now, what controls the landslides? Okay, what are the major factors that controls landslides? So we say that mass movement depends on balance of forces acting on slope. So if you interfere or disturb this balance, then you may face landslides. Okay. So one is the driving force that moves or pulls the material down slope, and another is your resisting force, which tries to keep the material in place or which opposes the movement of material downslope. So one force is resisting the movement, another force is pulling down the material, okay, and keeping at the same place. Okay. So driving and resisting force can be increased. Okay. So driving force can be increased by increasing in slope angle. So if you vary the slope angle, there are chances of landslides. Okay. Increase in amount of material. So if you are increasing the load on the slope also, that can also result into the landslide. So here it is extremely important that if you are having a sloping surface and you are coming up with any construction on it, you need to understand whether it may result into the slip in future or not, because you are increasing the load on the slope. Then either it is by the natural processes or human activity. For example, turbulent currents in river channels lead in tremendous erosion of side banks along bends. Okay. Results in slumping of bank material into the river channel, and this exactly happened during the Uttarkashi flood. Okay. As we have seen in the previous lecture, that there was a bank erosion along the bends of the river bank, and that resulted into the collapse of the houses which were sitting close to the river channels. decreasing resisting force. Okay. So, one is the driving force, another is resisting force. What parameters will affect in reduction of the resisting force? One is the saturating slope material with water. So, if you are having a loose material and if you keep on adding more water to it, it may lose its shear strength and result into the slip. Okay. And then other is shaking of slope during earthquakes. This again will reduce the or decrease the shear strength of the material sitting on the slope. So, we have a couple of important factors. So, one which we can look at is very important is the slope. Then we are having the saturating the slope by water, or we are reducing the shear strength by shaking. So, this you should keep in mind when we are discussing further this topic. Okay. So, two factors mainly triggers the movement on the slope. One is the downslope movement of slope material under the influence of gravity and flowing water. Now, causes of landslide, if in total if we take, okay, the main factor that influence slope stability is gravity and is responsible for the mass moment. So, on a flat surface, suppose if you take, the force of gravity acts downward. So, nothing will happen. Okay. If you are having a flat surface, no movement will take place, because your normal stress is acting perpendicularly to the ground surface, and you have no forcing, no forces which are trying to drive this material. Okay. So, here you are having the gravity, what we are talking about, this is a normal stress, okay, is equal to the gravitational force, whereas here you are having the shear stress, okay, that is the driving force, which is almost 0 here, because no slope angle is available. So long as the material remains on the flat surface, it will not move under the force of gravity. However, on a slope, the force of gravity can be resolved in two components. So, you have one, the normal stress, and another you are having the shear stress here, and gravitational force will be always perpendicular irrespective of the slope here, and this is what we call the angle of repose. So, if you change the angle of repose, then you may result into the landslides. So, here you have the normal stress is equal to the shear stress. So, until this is under the equilibrium, then nothing will happen, okay. And all material on the earth's surface has certain angle of repose, so beyond which it will slip, okay, if you increase it. So, if you increase the angle here, and if you vary the shear stress, okay, and if it is greater, that is the shear stress is greater than the normal stress, then you result into the landslide. So, stresses in terms, if you take, okay, when a force is applied to a solid body, stresses, that is force per unit area, are transmitted within the material, and we have the shear stress and we have normal stress. Okay. Now, gravity imposes a shear stress tau on all the slopes. Okay. which you can give with the equation W, where W is the weight and sine beta, okay, that is the angle of the slope with respect to horizontal, and normal stress is W cos beta, and W is the weight of the material sitting on the slope. So, role of gravity on landslide. So, gravity acts as a weight per unit area on slope materials, producing a vertical stress V, okay, and you have a normal stress and you have shear stress, okay, and this is your angle, or you can say it is theta or beta, whatever it is you want to take, is the angle of shear or angle of friction. So, the vertical stress V can be resolved into two components acting at right angles to each other, okay, that is between GT and GP. The relative size of GP and GT depends on the angle. So, if you change this angle, the relationship between the normal stress and the shear stress will change. Eventually, if you increase the slope angle, the shear stress will increase, and that will result into your landslide. So, until GT or shear stress is equal to GP normal stress, then no landslide will take place. So, slope angle and shear stress, if you take, okay, suppose it is 20 degrees, you have almost like here you are having the normal stress greater than the shear stress, okay, nothing will happen here. If you are increasing the angle, slope angle, still until some point it will remain the same, okay, but if you increase further, then here what you are having is GT, that is shear stress is greater than the normal stress, and eventually will result into the landslide. So, GT is large enough to produce the slope failure. So, in terms of the human interference, if you increase the slope angle by excavation, then you may face the landslide. So, water within the slope complicates this simple picture, okay. So, even though we keep on talking about that GT should be equal to GP to have a stabilized slope, but in the case where you are putting more water, then it may result into the landslide because of the loss of shear strength of the material. So, water content and normal stress, why it happens? Because it result into and give rise to some buoyancy effect. Okay. So, here we have the water saturated material which will result into the buoyancy effect, and that will change your normal stress. So, as soon as you have disturbed the normal stress, and normal stress here because of the water interaction will be reduced, okay, and that is what we call the effective normal stress. As soon as this has been reduced, this will have the hold to drive the material downslope. Okay. So, water filled slope will have pore water pressure, which gives buoyancy to overlying material acting in opposite to the normal stress, producing a smaller effective normal stress. Okay. So, we will have this buoyancy effect which will result into the effective normal stress, where effective normal stress is normal stress minus the buoyancy effect. So, as we were talking about that, as soon as this has been disturbed, this will take up the work, okay, and that will result into the slope failure. So, strength of the slope material, okay. So, shear strength is the most important characteristic in terms of the resisting shear stress, and the shear stress is related to one, the cohesion and the effective normal stress as given by the Coulomb-Terzaghi equation, which includes the importance of the internal friction of the material, which includes the angle of the slope. So, internal friction of the material will be affecting the shear strength. So, for example, if you are having gravelly deposits, and if you are having sand, and if you are having clay, the internal friction will be different for different material. So, shear strength, either we say SH, will be given, this is Coulomb-Terzaghi equation, where C is the actual cohesion of the material and phi is the angle of internal friction, and the shear stress is given as the weight of the material and the slope angle. So, important part is here that again what we have been discussed, that the internal friction is extremely important, and this can affect the cohesion of the material. So, here the water can play an important role in terms of changing the shear strength of the material. So, Coulomb-Terzaghi equation, as discussed in the previous slide, can be given as total shear strength tau, okay, cohesion of the material, normal stress, and phi is the coefficient of internal friction. So, if you have this information, you can talk about that what will be the shear strength of the material. Now, strength of the material on slope, you can have one example here, that if we have shear stress and we are talking about the shear strength, okay, then we are interested when we are talking about the shear strength or the shear stress, okay, that is the mass of the material is extremely important, slope angle, and then we are talking about the shear stress, okay. So, where shear stress is given as W sin theta. So, W can be further classified as mass into gravity Newton per kg. So, if the weight is, for example, 500 kilograms and the angle of slope is 30 degrees, okay, then weight, that is 500 kg into the acceleration, which is g, will give you the mass as the weight as 4,900 Newton. Okay. So, shear stress will be your angle into the weight here, okay. That will be around 2,450 Newton. Whereas shear strength, as we were talking about, that this will depend on the cohesion, okay, internal friction, that is SH, where we are talking about the cohesion and the internal friction of the material. Okay. Total shear strength, cohesion, normal stress, and 10 phi is the coefficient of internal friction. This parameter, that is the shear strength and shear stress and shear strength, will be helpful extremely when we are talking about factor of safety of any material sitting on a slope. So, friction is the result of compressive forces that holds the particle together. It is derived from two components, that is angle of internal friction, that is a measure of frictional resistance of the material. The normal stress, that is the effect of gravity operating at right angle to the slope or shear surface. Okay. So, these are the two components. So, as slope increases, normal stress decreases. So, under seismic loading, because we were talking about the two factors, either we reduce the normal stress because of adding more water to the sloping surface or the material sitting on the slope, or either because of the ground shaking. So, under ground seismic loading, which is triggered by earthquake, ground shaking, seismic loading resistance forces becomes something like this, okay, where you have the two components which have been added here, Fv and Fh. Okay. Because during ground shaking you will add on the vertical as well as horizontal forces. So, this two parameters again has to be taken into consideration when we are talking about the strength of the material. The frictional resistance depends on difference between the applied total normal stress and the pore water pressure, that what we were talking in the one of the slide before. Okay. And that will be your effective normal stress or effective stress. So, this is your normal stress and this is your pore water pressure. So, shear strength becomes when you are putting the component of the pore water pressure. This will be your sigma prime. And of course, the internal friction will also change. So, where C prime and phi prime are modified parameters with respect to the effective stress. So, this is important in terms of when we are talking about the factor of safety. Factor of safety has been given as shear strength by shear stress. So, if you take the normal Coulomb-Terzaghi equation, we have this equation which will give us the factor of safety. So, where the factor of safety is greater than 1.3, the slope is stable. Where the factor of safety is less than 1, then the slope is actively unstable. Where the factor of safety is between 1 to 1.3, the slope is conditionally unstable. Okay. So, what is extremely important for us, the parameters which we have discussed in previous slides. Okay. That is the normal stress, okay, will be extremely important when we are talking about the material sitting on the slope, okay, and if they are getting saturated by water, okay, or if we are changing this parameter and this parameter because of seismic loading, and this will depend upon the, so shear stress will depend upon shear stress will depend upon the weight and the slope angle, whereas here we are talking about the stress. So, again where we incorporate the cohesion, then we incorporate the internal friction of the material and the normal stress. So, this one has to keep in mind when we are talking about the factor of safety. Factors affecting the slope processes, internal factors and external factors. Okay. So, slope angle or relief, lithology of the material on the slope, groundwater and rainwater, that is what we are talking about, the runoff, then climate, in which area the slope is present, okay, and what type of material is there. Then of course the vegetation, then geological structures. Then external forces, earthquakes, tectonic activities in the areas, volcanic activities, human influence, which will destabilize the slopes. Okay. So, these are all factors. Okay. So, it is not the one single one which will act upon or affect the landslides, but there are several. Okay. So, please keep in mind what the parameters we talked about in terms of the shear strength and shear stress, okay, which includes all, that is, we are talking about the slope angle, we are talking about the internal friction of the material, we are talking about the groundwater which will affect your normal stress, and of course the climate, because this will be extremely important when we are talking about in terms of the precipitation. Vegetation to some extent will hold the slope, and then geological structures. So, if you are having faults and fractures, that eventually will affect the shear strength of the material. Earthquake will result into seismic loading, okay, because of the strong ground shaking. Volcanic activities, as we were talking in the introductory lecture, that it can result into the landslide, okay. And the human influence, if we reduce the or we excavate the material from the slope, or we are overburdening the weight on the slope, increasing the slope angle can result into the landslide. So, these are two factors, okay, internal and external factors, which will also affect the slope processes. So, internal causes, influence of slope provides favorable condition for landslide. Steeper slope are prone to slippage of land. It is known that most of the material are stable up to a critical angle, that is what we were talking about, the angle of repose. And for example, it varies from 30 degrees for unconsolidated sediments. So, if you are having loose sediments, it will remain stable until 30 degrees, up to 90 degrees for massive rocks, and for jointed rocks it is up to 60 to 90 degrees. So, groundwater or associated water is one of the main factors responsible for the slippage. Suppose the hard or massive rocks are underlain by softer rocks like shale or clay beds. Okay. So, they have different shear strength. So, if you are having the massive rocks sitting on the surface, that does not mean that that area will not slip, okay, because you are having a softer material which is having comparatively less shear strength and will eventually decrease the normal stress, okay, when you are pouring more water on the slope, okay, and if it becomes oversaturated, it will result into the mass movement. So, when rainwater percolates through some fractures or jointed areas, jointed regions, okay, the clay beds become very plastic and acts as a slippery base, which enhances the chances of loose overburden to slip downward. So, you have affected here the normal stress of the material on the slope. So, the holding forces which were acting before the percolation of the water, okay, is changed. So, water is the most powerful solvent which not only causes decomposition of the minerals, but also leaches out the soluble material of rock and reduces the strength. Okay. So, this will reduce the shear strength of the material. So, along with the slope, the angle of the slope, what type of material is on a surface is important. So, for example, lithology, if we take into consideration rocks which are rich in clay, montmorillonite, bentonite, mica, calcite, gypsum, etc., are prone to landslide because these minerals are prone to weathering. So, we will discuss this part again and in the next lecture. Thank you very much.